Okay, in the second video we will continue with our review. So we do a few questions from the final in May 2018. Again, you can pause the video right now, try to solve this question by yourself before you look at the solution. Okay, that's the best way to learn this. Okay, so we're given two matrices A and B, both of them being 4 by 4. Maybe that fact will play certain role in our solution or not, such that, and these are the condition givens, right? The determinant of a squared times b is 20, and determinant of a times b squared is 50. Okay, the first question is find the determinant of a and the determinant of b. Okay, so let's see how we're going to use these conditions here. So what do we know? We know that if that you can find the determinants of a and b if they are squared matrices of the same size, let's say m and n, then the determinant of m times n, if these are matrices, determinant of a times b would be the determinant of a times the determinant of b. Okay, I'll use this fact in order to write this down. So the determinant of a squared times b is equal to the determinant of a squared times the determinant of b, and determinant of a squared is the determinant of a times a as a matrix, right, times the determinant of b, which is the determinant of a times the determinant of a, and that's some scalar, some constant, times the determinant of b, and that's given that is equal to 20. On the other hand, the determinant of a times b squared, well, I'm just going to go slowly, step by step, writing everything here. So that's the determinant of a times the determinant of b squared. Well, that's the determinant of a times the determinant of b times b, and by the same property, you can write this down as the determinant of b times the determinant of b. So the determinant of a times the determinant of b times the determinant of b is equal to 50 by this condition here. Well, what do we have? We have two unknowns. One of them is the determinant of a, and the other one is the determinant of b, and we have two equations. So from the first equation, you can write down that the determinant of b is equal to 20 over the determinant of a times the determinant of a, that's the determinant of a squared. And I'll keep this aside, and I will plug this idea into the second equation, obtaining what? The determinant of a times the determinant of b is 20 over the determinant of a squared times determinant of b, again 20 over the determinant of a squared, and that's equal to 50. And now I have an equation in one unknown, so let's simplify this. The determinant is a scalar, so we cancel that. And then we have 20 times 20 is 400 over the determinant of a cubed is equal to 50. Cross multiply, you get 400 over 50 is equal to the determinant of a cubed. 40 divided by 5 is 8 is equal to the determinant of a cubed. And take cubed root on both sides. As the determinant of a, you get that 2 is equal to, is equal to the determinant of a. Okay. If you plug this back in here, we get that the determinant of b is equal to 20 over the determinant of a, which was 2 squared. 20 divided by 4 is equal to 5. And that's how we have obtained the determinant of a and the determinant of b. B is a very straightforward question. Just ask us what is the determinant of A inverse, and we know that the determinant of A inverse is equal to 1 over the determinant of A, and I have the determinant of A, that's 2, so the answer is 1 squared. Not 1 squared, 1 over 2, sorry. And finally, just a little bit more just a little bit more solution in here. Okay, C, find the determinant of 3 times B transpose. I know the determinant of B and the determinant of B transpose is the same, but first, how I'm going to deal with this, 3, right? So just as a side note, if I have, let's say, 2A, 2B, 2C, 4D, 4E, 4F, GHI, and I'm looking for the determinant, okay, I can factor a constant from each row. So this would be 2 times the determinant of A, B, C, 4D, 4E, 4F, G, H, I, right? So, and then if I want to factor 4 from the second row, I would get 2 times 4, and then A, B, C, D, E, F, G, H, I, okay? But what will happen in our case? B is 4 by 4 matrix. B is a 4 by 4 matrix. That means that B transpose is also 4 by 4 matrix. When I multiply it by 3, that means that this constant multiplies every row by 3, right? So we would get, I don't know, A, B, C, D, E, G, H, I, J, K, L, M, N, O, P. And when I multiply this by 3, that means that every single term will be multiplied by 3, okay? And when I'm going to take the determinant here, right, I have to take 3, factor out 3 from each row, times 3 from the second row, times 3 from the third row, times 3 from the last row. And then I have this matrix A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. But the fact is that I have here 3 to the power of 4. Why? Because of the fact that B is a 4 by 4 matrix. So this is equal to 3 to the power of 4 times the determinant of B transpose, but determinant of B transpose is the same as the determinant of B. And we evaluated that right here, that's 5. Determinant of B is 5. So I get 3 to the power of 4 is 3 squared times 3 squared. 3 squared is 9, so 9 times 9 is 81, times the determinant of B is 5. And now you just evaluate this product, and how much 1 times 5 is 5, 8 times 5 is 40, we get 405. Okay, so just be careful how you factor out so when you're looking for the determinant of a constant times the matrix, be careful when you factor out that constant, it's gonna go out, but it's going to be raised to the power of how many rows or columns that matrix has. Okay, next question is the Cramer's rule. Okay, so what is a Cramer's rule? It gives us a solution of a particular value that you're interested in through by finding its determinant. Okay, so if you have xi would be equal to the determinant of ai divided by the determinant of A, where AI is what? Is the matrix A, okay? Such that its ith column is replaced by the solution here that's given, right? Not by the solution, but by the constant term in the either the system of linear equations or the matrix equation. Okay, so let's see what the question says. We're given a 3x3 matrix A, B, C, D, E, F, G, H, I, and we say that the determinant of this matrix is some non-zero value n. That means the determinant of this matrix A, B, C, D, E, F, G, H, I is equal to n. Okay, we are asked to use the Cramer's rule to find the value of x3 only, okay, in this system of linear equations. Okay, so that means that x3 is equal to what? Is going to be equal to the determinant. In the denominator, I have the matrix of the matrix equation, so that's 1, 0, 0, 0, 0, A, B, C, 0, D, E, F, 0, G, H, I. So the determinant of this matrix. And in the numerator, I have the determinant of AI. Consisted of what? Consisted of the columns of A, except that in the third column, instead of writing the third column, I'm going to write the constant term. So I have 1, 0, 0, 0, 0, A, B, C. And now you see I'm changing the third column and I'm putting this column 0, 3B plus 2C, 3E plus 2F, 3H plus 2I, and in the last column is just 0CFI. And now once I calculate this determinant and this determinant, I'm done, because I'll have a scalar divided by scalar and I have the answer. So on the side here, first I will find the determinant in the denominator. So the determinant of this matrix 1, 0, 0, 0, 0, A, B, C, 0, D, E, F, 0, G, H, I is equal to, well, I'm going to use a cofactor expansion about the first row. So I have 1 times the determinant of A, B, C, D, E, F, G, H, I. But this determinant here is given. That's equal to n. So 1 times n, that's equal to n. So in the denominator, I just have n here, right? By the way, I didn't continue with the cofactor expansion because all the other terms in this row were 0. So this is 0 times any value of the submatrix of the determinant of the submatrix will be 0. And now what are we left with? Well, we're left with evaluating the determinant of this matrix. So let's do that. So the determinant of 1, 0, 0, 0, 0, A, B, C, 0, 3B plus 2C, 3E plus 2F, 3H plus 2I, 0, C, F, I. And now, in order to solve this, I'm going to do some column operations, and we know that, I told you that when we are evaluating the determinant, we are allowed to do this kind of column operations. Okay, so here I'm going to say column 3 becomes column 3 minus 2 times column 4, and I get 1, 0, 0, 0, 0, A, B, C, 0, 3B, 3E, right, 3B plus 2C minus 2C, that's only 3B, so 3H, and then 0, C, F, I. If I do cofactor expansion about the first column again, I get 1 times the determinant of this submatrix here, A, 3B, C, B, This is D, I'm sorry. Three E F C 3HI, and now I'm going to factor this 3 from the second column, so that's 1 times 3 times the determinant of the matrix ABC, D, E, F, give me a second here, this is a mistake here, D, I copied this wrong, so I'm substituting this column, so this is D, so that's a mistake, and this is G, and this is I. So this is G, and this is I, G and I, and then G and I, G, H, I, sorry about that. So I have 3 times, and the determinant of this matrix, as we said in the beginning, it was given, it's n, so 3 times n, and we're done. We have evaluated how much is the value of x3, that's 3n divided by n, that's equal to 3. The next question is kind of a long question. So we're given 3 points A, B, and C, right? In R3, okay? And we're asked different questions about this situation, okay? So let's start from the beginning. We're given the points A, B, and C. The first question is find the distance from B to the line that goes through the points A and C. So if this is B, and this is A, and this is C, we're asked how much is this distance. Well, how to do that? We already talked about the situation. I can define this vector here from A to B. Okay, I can project it onto the vector AC. Okay, that projection is going to be this one right here. That would be projection of AB onto AC. Okay. If I find the difference between the projection and the vector AB, I'll find this vector right here. The magnitude of that vector is going to be the distance. Okay. So first of all, let us define what is AB. Okay. So that's the coordinates of B minus the coordinates of A. 2 minus 3, negative 1. 1 minus 1, 0. 3 minus 1, 2. And the vector AC, this vector right here, AC, we need it in order to find this projection. So that's the coordinate of C minus the coordinates of A. 1 minus 3, negative 2. 0 minus 1, negative 1. 3 minus 1 is 2. Okay? How do we find this projection? So the projection of AB onto AC is the vector AB dot product AC. In the denominator I have AC dot product AC, and all of that, so this is going to be a dot product, a scalar in the numerator, scalar in the denominator, that ratio is going to be a scalar, times the vector AC. So basically I have to figure out how much this constant is first. Okay, so let's do that. AB dot product AC, so that's negative 1, 0, 2, dot product negative 2, negative 1, 2. Negative 1 times negative 2 is 2, plus 0 plus 4, that's equal to 6. Okay, so this is 6 over AC dot product AC. So that's negative 2, negative 1, 2, dot product negative 2, negative 1, negative 2. We get 4 plus 1 minus, and this is positive 2, my bad. So plus 4, and that's equal to 9. So 6 over 9 times the vector AC, negative 2, negative 1, 2. And we can simplify this, divided by 3, I get 2 over 3 times the vector negative 2, negative 1, 2. So what is this vector? This vector is right here. This vector. Okay? Now in order to find the distance is the magnitude is equal to the magnitude of what? Of the difference of these two vectors. Okay? So you can say AB minus, so AB minus the projection gives you this vector right here. Well, how much is that vector? So AB, which was here, negative 1, 0, 2, minus negative 4 over 3. Okay, this is negative 2 over 3, and the last one is 4 over 3. And I'm looking for the magnitude of that. So let's see. Negative 1 plus 4 over 3 is 1 over 3. 0 minus negative 2 over 3 is positive 2 over 3. And finally 2 minus 2 over 3. Sorry, 2 minus 4 over 3, that's 6 minus 4 over 3, that's 2 over 3. And the magnitude of this vector is the square root of the sum of squares, 1/3 plus 2/3 plus 2/3, which is square root of 1 plus 4 plus 4 over 9, that's square root of 9 over 9, and that's equal to 1. Okay, so one more time, how do we find the distance from B to the to this point? Sorry, how do you find the distance from B to this line? I defined the vector AB, I defined the vector AC, I projected AB onto AC, that gave me this blue vector right here. If you find the difference between AB and this vector, I'll get the red vector. The magnitude of the red vector is nothing else but the distance from B to that point. Okay, question number B. Find the point on the line containing AC that is closest to B. So we have the same situation, right, for B. This is the point B. This is the point A, and this is the point C. So what are we going to do? Okay, from the previous picture, I defined AB, right? I projected that one onto AC, and I got the vector, this vector right here. Let's call this point M. Okay, so I want to find the point on the line. I want to find the point with coordinates X, Y, and Z that is closest to B. There are different ways how to do this, but one way is, since we have already found the projection, right? So this vector AM is nothing else but the projection of AB onto AC, and we have the coordinates of that, that's 2 over 3, negative 2, negative 1, 2. Okay? The question is, what are the coordinates of M? Well, if you have 2 points, right, let's say P, and with the coordinates xp, yp, and zp, and if you have the point Q with coordinates xq, yq, zq, then the vector pq is equal to the coordinates of the point Q minus the coordinates of the point P. Okay, now we have something different. I have the coordinates of the vector AM, and I have the coordinates of the point A. I need the coordinates of the point M. Okay, so x, y, z minus A is the vector AM, and the points of A are 3, 1, 1, is equal to 2 over 3, is equal to this projection, negative 2, negative 1, 2. From here, x, y, z, or the coordinates of the point M, is 3, 1, 1, plus 2 over 3, negative 2, negative 1, 2. And how much is that? This is 9 minus 4 over 3, so that's 5 over 3. 1 minus 2 over 3 is 1/3. And 1 plus 4 over 3 is 7 over 3. So those are the coordinates of the point M. The next problem is find the cosine of the angle theta formed by AB and AC. So again, the same picture, right? This is the vector AC, and this is the vector AB. This is the vector theta between them. Okay, so we know that cosine of theta is equal to the dot product between AB and AC over the magnitude of AB times the magnitude of AC. Now, if I'm not mistaken, we have already evaluated this dot product. AB dot product AC is 6 over, and now we have to find the magnitude of AB. AB has coordinates negative 1, 0, 2. That's equal to square root of negative 1 squared plus 0 squared plus 2 squared. That's square root of 5. So square root of 5 times, that's this length, the length of this vector, the magnitude of AC. And AC has coordinates negative 2, negative 1, 2. That's equal to square root of negative 2 squared plus negative 1 squared plus 2 squared, and that's square root of 4 plus 1 is 5 plus 4 is 9, which is 3 times 3. Well, you can cancel these two, and the answer is 2 over square root of 5. If you want to rationalize this, you can write it as 2 square root of 5 over 5. That's the question part C. Find the cosine of the angle theta formed by these two angles. The next question is, again, you have to, if you know this formula, then this question